For centuries, we've believed space is empty, a silent, endless vacuum. But what if that's wrong? What if space is not empty at all, but filled with a hidden medium, an invisible field that shapes gravity, carries light, and gives rise to time itself? This is the theory of space particles, a new way to understand the universe. According to this idea, when mass enters space, it disturbs this medium, creating gravity. Light flows through it. Time depends on it. And where this medium collapses entirely, in the heart of a black hole, space vanishes. And with it, so does time. For centuries, science has tried to explain the force of gravity and the nature of space. Isaac Newton first described gravity as an invisible force acting at a distance between masses. Later, Albert Einstein revolutionized our understanding with his theory of general relativity, suggesting that gravity is not a force, but the curvature of spacetime caused by mass and energy. In this view, massive objects like planets and stars bend the fabric of spacetime, and other objects follow those curves. Stephen Hawking expanded this framework to explore black holes, regions where spacetime becomes infinitely curved, trapping even light. According to mainstream science, space is a stage, a dynamic but empty structure where matter and energy interact. But is space truly empty? Or is there something deeper? Space is not empty, it is filled with countless tiny, unknown particles, spread evenly everywhere. These particles form a kind of invisible fabric of space. When an object moves into this space, it disturbs the surrounding particles. Imagine dropping a pebble into calm water, ripples spread out, and the water around the pebble becomes denser. Similarly, the space particles cluster more densely around the object because the object's presence disrupts their normal distribution. This local increase in particle density creates an effect we experience as gravity. In other words, gravity is the result of these space particles getting compressed or concentrated around an object, pulling other objects toward that region of denser particles. Based on this understanding, space is not truly empty but filled with countless unknown particles that form an invisible, continuous medium. Light requires such a medium to travel, just as sound needs air or vibrations need a surface. These space particles provide the pathway that allows light to propagate at a constant speed. Because they are uniformly distributed, they enable light to maintain its speed and preserve its properties, such as wavelength and energy, over vast distances. This suggests that light's ability to travel consistently through space is not due to a vacuum, but because of this hidden structure of space particles that silently support and guide its motion. In current science, a black hole is understood as an area in space where a massive amount of matter is squeezed into a tiny region, creating such a strong gravitational pull that it warps spacetime itself. This extreme warping forms an event horizon, a boundary beyond which nothing, not even light, can escape, making the black hole appear completely dark. However, in this new perspective suggests that space is actually filled with tiny invisible particles that act as a medium for light and gravity. According to this view, a black hole isn't just a region of warped spacetime but a place where these space particles vanish entirely, creating a void with no medium for light to travel through. Without this medium, light cannot escape, and gravity intensifies at the edges where the particles are pulled in, making black holes zones where the very fabric of space is missing rather than just distorted. This new theory presents a bold new vision of space, not as a void, but as a dynamic medium filled with unseen particles or energy. Rather than replacing the laws of physics, it deepens and extends them, offering fresh explanations for gravity, light, black holes, and dark energy. By redefining space as an active, energetic structure, it opens the door to transformative breakthroughs, including new technologies and even the potential for faster-than-light travel. This perspective challenges conventional thinking and encourages a new era of discovery, pushing the boundaries of science toward a deeper understanding of the universe. The universe is full of mysteries waiting to be unraveled. Understanding the true nature of space might just be the key to unlocking new dimensions. Credits: Mossadegh Shireen.